All right, we're working on a review guide for sequences and series. Questions 1 and 2 ask us to evaluate using sigma notation. Question number 1 says we're going to sum the terms from the first up to and including the sixth term using the formula 3k minus 7 to generate the terms. Our first term plus our second that's like the expanded form. Then we can evaluate each of those, add them up, and we would get 21. Same idea in number 2. Add the first up to and including the third term using the formula k squared plus 4 to find the terms. Our first term, our second term, and our third term, all added together is 26. So the terms listed are the expanded form, and the sum is the final answer. In our next set of questions, we're looking to determine if each sequence is arithmetic or geometric, and then find the formula for the nth term, which means write the rule or the equation. One to negative 2 to negative 5, we're subtracting 3 each time. So we have a common difference. So that is arithmetic. We know that the first term is 1. Our common difference is negative 3, and that's all we need to fill in to write that general form. We can distribute and simplify. And that would give us a sub n equals negative 3n plus 4. As we look at number 4, there is no common difference. We're not subtracting the same amount to get from term to term. So we're going to create a ratio of the term on the right divided by the term on the left to find if this is geometric. And 18 over 24 gives us 3/4. And we can double check 13.5 over 18 is also 3/4. That's our common ratio. We also know that our first term is 24, and that is enough to write our geometric rule or equation. We start with our first term times the common ratio to the power of n minus 1. As we look at example number 5, 2, 4, 6, we are adding 2 every time. So this sequence is arithmetic. We've just determined that our common difference is 2. Our first term also happens to be 2. That's enough to write our rule. A sub n equals 2, the first term, plus 2, the common difference, times n minus 1. We can distribute, combine like terms, and write the general rule as 2n. As we look at number 6, clearly there's not a common difference, so we're going to come up with our common ratio. 2 divided by negative 1 gives us negative 2. So does negative 4 divided by 2. So our common ratio is -2. Our first term is -1, and we have enough to write the formula for this geometric sequence. A sub n is -1, -2, our common ratio, to the power of n minus 1. In questions 7 and 8, we're to find the common difference and the first term. So those are two unknowns, which means our approach can either be to use a system or to use slope. I'm going to solve these with slope. If the 7th term is 31, we can treat that as the point 7, 31. If the 20th term is 96, we can treat that as the point 20, 96. And then using the slope formula, that will tell us the common difference. 96 minus 31, the difference in the y values, over 20 minus 7, the difference in the x values, gives us 5. That's only one of our two unknowns. We still need to know the first term. So we need to set up our general rule. I'll do that first, filling in our common difference, which is 5. And to find our first term, we need to know a particular term as well as its position in the sequence. So I'll use 31 and 7. 31 is the term, it belongs on the left. And 7 is the position of the term, so it gets substituted for n. We go ahead and simplify. 5 times 6 becomes 30, and we can see that our first term is 1. So we know that our first term is 1, and our common difference is 5. We can use the same approach in number 8. Two terms that we can treat as 2 points. Position as our x value, and the term as the y value. And then we just need to carefully calculate our slope. So we'll do -47 minus -20 over 17 minus 8. And that gives us a common difference of -3. And again, we still need to find the first term. So we'll substitute that common difference back into our arithmetic rule. And we can use either point, 8 and -20 or 17 and -47 to find the first term. We'll use 8 and -20. -20 is the term, and 8 is its position. And a sub 1 happens to be 1 again. Our first term is 1. Our common difference is -3. Questions 9 through 12 ask us to use our general formula to solve for an unknown. Each general formula has 4 variables, so we are given 3 of those variables. In question number 9, I see that there's a common difference listed, so I know that that will be arithmetic. So we'll look at our formula sheet, and we'll plug in what we know. We know that the term is 93. We know that the first term is 12. The common difference is 3, and we're looking to find where 93 is in this sequence. So doing a little bit of solving, we can subtract 12 to give us 81. You can distribute here or simply divide by 3. Add 1, and n is 28. As we go on to number 10, there's a common ratio listed as 1/2, so we know this is geometric. And we're to find the first term if we know the sixth term is 3 and the common ratio is 1/2. Since this is geometric, our formula will be a little bit different. A sub n equals a sub 1 times r to the power of n minus 1. And again, we'll fill in what we know. We know the sixth term is 3. The term itself goes on the left. We're finding the first term, that's our unknown. Our common ratio is 1/2, and 3 is in the sixth position, so our exponent is 6 minus 1. This gives us 3 equals a sub 1. If we take 1/2 and raise that to the fifth power, it is 1 over 32. So the quick way to solve this equation would be to multiply both sides by 32. On the left, 3 times 32 gives us 96, and a sub 1 is alone. So that is our first term. Question number 11, 26th term, when the first term is 5 and the common difference is -6. So we're back to arithmetic, where we know we're looking for the 26th term. The first term is 5, and the common difference is -6. So using our arithmetic formula, we'll fill in the first term as 5, common difference of -6, and we're looking for the 26th term, so that's our n value. And then using PEMDAS, we'll simplify inside parentheses. We'll multiply and then subtract from 5 to tell us that our 26th term is -145. So we can write that as the 26th term is -145. And on to number 12. This is a geometric sequence because we see a common ratio, and we'd like to find the 14th term. Labeling what we know, the first term is 8, common ratio -2, and our n value is 14. Using our geometric formula, a sub n equals our first term of 8 times our common ratio of -2 to the power of 14 minus 1. Make sure you follow PEMDAS. You want to do the exponent first before you multiply by 8, or you can go to your calculator and carefully type this in, and our 14th term is -65,536.